Okay. You want lines through 4, 5, and 9, 4, and through 6, 4, and 4, negative 6. The x-axis needs to go out as far as 9. I'm going to do 8 because it's easy to subdivide 8 in half to get 4, and that in half to get 2, and then we get 6, and then 7, and 5, and 3, and 1 in between. So 9 is going to be at an equal distance here, and if you do this, as I've often recommended, you get pretty even intervals between your numbers. Instead of having all these bunched up and then wider spacings out here, which totally screws up your graph, okay? So let's make sure we're doing that. Not everybody is being careful about getting equal spacing. Just putting down marks. Some marks are 3 times as far between as others. Okay? You don't want that to happen. Okay, then here we've got to go down to negative 6, so I'll go all the way down to negative 8 and do the same thing. And then I'll go up to positive 8, which means I'm going to have to extend my axis up here a little ways. Let's say here's 8. This is not all that accurately drawn, but making some effort to do it as accurately as possible without taking a long time to do it, right? So then we subdivide here. And these might look like they're a little closer than these. My 8 is not quite big enough, but it's going to give me a reasonable graph. And I don't expect you all to do a whole lot better than I did, because then you're showing off and make me feel bad and I have to take off points. Not really. Okay? I'm glad if your work is neater than mine. Okay, so 4, 5 is going to be here. There's 4 and there's 5 reasonably well. 9, 4. That thing's not going to have a whole lot of slope. Okay? And we want to label these points. Okay, when you do your work, you want to show what you've done. It's going to be required on a test, and there'll be a test coming up before long. We'll talk about that. But here's 4, 6, and here's 8, 4. Now down here we've got 6, well up here, we've got 6, 4. And that's going to mean that we're going to be able to get a pretty accurate intersection point, because this is so close to this line segment, right? So we're going to be able to do a pretty good job, because looking ahead, we know we've got 4, negative 6, which is maybe going to be about here. And now we draw our line. Okay? Okay, well, got a line here. And got a line here. Okay? Now the intersection point is going to be like 6.3 and 4.2. Maybe even 4.1 the way I've drawn it. Okay? Except I drew that dotted line a little bit below the center of my red dot. Should have been a little higher, so I'm fudging a little bit. Okay? Honest estimate, the way I drew the line would have been 4.1. Okay. Now, we want to get some. That's our estimated intersection, okay? Now, I actually know that's a bad estimate. I mean, it's not as good as it should be, because that means from this point to this point, we've got, you know, from the point 6,4 to the intersection point, this tells us that we've got a run of 0.3 and a rise of 0.2. Rise over run then would be 0.2 over 0.3, right? Which would be less than 1. But we see, just visually, the slope of this line is a lot bigger than 1, right? The slope of this line is 2 or 3 or more, okay? So the slope between here and my estimate isn't good. So my estimate's going to be off a little, but it's so close to this point that we're still going to get a pretty good result, okay? But based on the information we have, it's not a particularly great estimate. But at this point, I'm not expecting a particularly great estimate, just a reasonable estimate, okay? We want to get the idea of simultaneous equations starting with these graphs. Okay. And most of you do have the idea, because most of you did the assignment and did pretty well on it, so very well, okay? Of course, in the assignment, you're graphing things by using your mouse to locate points and stuff like that, which I think is far inferior to what you get if you draw it by hand, which is what I'm having you do here. Okay, so anyhow, and you should be able to do it either way. If you can do it one way, you should be able to do it the other, right? And it seems like from what you're doing, you can. Okay, anyhow, there's our estimated intersection. Now we've got to get the equations of these lines. You could use a formula for the slope, okay? But as I've said, I want to see the fundamental triangle. If you're doing this by hand, I want to see that, and I want to see it completely labeled. Because the fundamental triangle is fundamental. The formula follows from the fundamental triangle, okay? It follows from rise over run. So slope is not y2 minus y1 over x2 minus x1. It's rise divided by run, which is then y2 minus y1 over x2 minus x1. You start with rise divided by run. And rise divided by run is depicted by this fundamental triangle. So, I draw the fundamental triangle. I draw arrows. I go from left to right. I pretty much always do, but you're free to go right to left if you want to. As long as you do it the same both ways. Okay? Okay. My blue chalk is right here. No. Okay. Good piece of blue chalk. I want to distinguish these triangles since some of the triangle comes so close. Okay, so rise equals what? It's 4 minus negative 6. Which is 10. Okay, it's 4 minus negative 6 because you're going from negative 6 to 4. You go from here to here. From here to here is 10 units because 4 minus negative 6 is 10. Not because it's y2 minus y1, although it is. So once you've done the fundamental triangle, you can do your y2 minus y1 over x2 minus x1 and see if it agrees. I want to see the fundamental triangle, okay? And run, I'm going to draw another fundamental triangle down here, although I'm drawing the rise on one triangle and the run on the other just because it's easier to label that way. Everybody understand what I'm doing? The run here is going to be the same as the run here. And the run goes from x equals 4, I don't have room to write it. Bonehead mistake. It's not. Yes, it is, never mind. Okay. Don't even think about what I was doing. The run is going to be from 4 to 6. And that's 2, right? So the slope is and I'll put that, don't really have a good place for it. I'm going to do 5 with a box around it. It's closer to this segment than it is to this segment, so it applies to this one. Okay? And then, just looking at it, it would have been better to draw the triangle over here, even though it does go through some of my labeling. Over here, I need to draw a bigger picture of it. Okay, so the run is 8 minus 4. I don't have a .84. I have a .94. Well, this makes everything a little less accurate. Point should be 9.4. So now there's my triangle. Okay, so the run is 9 minus 4 equals 5. Okay, x coordinate minus x coordinate here is 9. 4 from 4 to 9 is 5 units. Not because of a formula, but because of a picture. Okay? Don't skip the picture for the formula. Have I said that before? No. Okay. Yeah, keep saying it because it's really important and people aren't always doing it. Okay, then the rise. Well, we're from, I got this point in the wrong place. It should be up here at 6, right? Somebody being too careless. So I want you all to get in the ball, will you? Okay. Okay, well, so my estimate's not going, my estimates keep getting worse. Everything I do, my estimate gets a little worse. Okay, anyhow, the rise, if you had drawn this correctly, it would be from 6 to 4, and the rise is going to be 4 minus 6 equals -2. So the slope equals, I want to see all this written out. I want to see you reinforcing the rise over run idea and not skipping to a formula, right? So you really understand it. Then later when you use the formula, you'll know what it means. And you'll be able to use that knowledge to understand things that you otherwise wouldn't. Okay, so rise over run is going to be -2 over 5. Okay? So there's your slope. So we write the slope here. -2 over 5. Okay. Now what's the equation of the line? Well, I'm not going to require this. This is why I'm going to do it. Well, actually, I'm going to do it a little differently right now. There are many ways to do it. This line is y equals mx plus b, m equal 5. So, if I use the point 46, we get 6 equals I don't want to use the point 46 because it's not on this line. It's 4.5, but it is 4.5. So why did I write 4.6? I feel okay. Apparently something's not working right. It should have been 4.5. Use corrections to use 4.6. Okay. So it's and m is not 5 for this one. M is negative 2/5. Okay, so it's 6 equals negative 2/5 of x, which is 4, plus b. Okay, I might have lost the thread there because I made a couple of mistakes. Try to follow the thread when I do this one. This is, again, this is mx plus b, m equals 5. Using either point on this line, I'll use 9/4 because there are no negatives. We'll avoid the confusion of negatives. Either point will work. If we plug the coordinates 9/4 into this equation, we get 4 equals 5 times 9 plus b. Okay? So, I wrote my b backwards, it looked like a 6. Okay? Now, this is what we get, just a summary of what we get up here. What's the equation of the second line? M equals 5. So we get right out here. This is 9. That's your y coordinate of that needed to be erased anyhow. It's 4. The y coordinate is 4. and the x-coordinate is 9. So we get this. And we see that b is negative 41. I'm going to go through the step. That's 45. Subtract 45 from both sides, you get negative 41. Over here, negative 2/5 of 4 is negative 8/5, but let's do the usual. Multiply both sides by 5. I'm not going to belabor that. I just multiply by 5. I get 30 equals negative 2 times 4 plus b. So negative 2 times 4 is 8. And this makes no sense at all. Oh, I just did what I keep telling you not to do. I didn't multiply b by 5. Meaning I should have written out all my steps as well. But I just pretending to make that mistake so you learn a lesson. Okay, not really, I made it. So there's 5b, right? Now again, I've just multiplied both sides by 5. Every term gets multiplied by 5. So that b is 38 over 5. Now incidentally, just to check, that's 7 3/5. And I didn't really draw 4/6 here. I drew the point 4/5. I should have been 4/6, which would have raised the line a little bit, and it would have gone between 7 and 8 if I had, I think. Who knows what would have happened. I got the chalk on the board, but that's what it should have done. So that's reasonable, and this is reasonable, because this is a pretty steep line. It's not going to hit the y-axis for quite a while. Negative 41. Well, it looks like it's going to be less than that. It looks like it's going to be maybe negative 20 because the graph isn't perfect. Okay? But let's see if it works. So the equations are, well, m is 5, b is negative 41. Y equals 5x minus 41. And here, y equals mx plus b. That means you're going to get y equals negative 2/5 x plus 38/5. Somebody have a... Okay, I heard somebody start to say something. Okay, and feel free to actually make a noise so I don't have to turn the camera off and crash the video. Okay. So there I have two equations, okay? Now, I can find a solution to these two equations. If both of these are true, then if I add the left-hand sides and add the right-hand sides, I'm going to still get a true equation, right? But better than that, I can multiply one of these equations by negative 1, which will give me a negative y. And if that's added to the y from the other equation, it's going to give me 0, and the y's are going to disappear. I'm going to end up with an equation just for x. Okay? So, multiplying the second equation by negative 1, I get negative y equals negative 5x plus 41. I think I'm going to get a correct solution out of this. I did something wrong here. Okay. Adding the equation, we get 0 equals what? Well, that's -5 2/5 x, right? Or -27/5 if you do the fractions. Now, the first problems of this nature that you're going to do for homework for next time aren't going to have messy fractions in them. But you need to be able to deal with fractions. So this is what you would run into on these problems, okay? So I didn't realistically expect that most of you were going to be able to work through all the fractions correctly. It gets messy. It looks like I've screwed something up, I don't know what, okay? Because it doesn't look like it's going to check out. Anyhow, you get -27/5 x plus what? Now I just, put the 5, -5 is -25/5, and -25/5 added to -2/5. Well, -25 and -2 gives you -27, so you have -27/5, okay? Now, if you just follow the procedure for adding fractions, that's what you're going to end up with. Got to know that. Don't want to stumble over that when you get into the MDE 61 and Math 161, okay? Okay, so anyhow, I got 205/5, and add that, and I get 243/5. So x equals -5/27 of 243/5, okay? And times -243/5. And coincidentally, that comes out -9. Okay? Now, I know that the point where x equals -9 is not a point of intersection. Which leads me to believe this -41 doesn't look, it looks like this thing's going to hit way before x equals -41. Gives me an idea that maybe I better check this. Is the slope really 5? Well, I'm going up 10. And I'm going over 2, so yeah, the slope really is 10. 10 over 2, which is 5. And we do have the point, no, that's right. Y is 4, x is 9. I'm kind of stuck, but I don't believe that -41. And this isn't -9, this is +9 because I have negatives here and here, okay? So something's wrong. X is not 9 at the point of intersection. That would be above both lines. I'm wanting that -41 to be like maybe a -25, -30, which is kind of what it looks like. I'm guessing -25 from the graph. I'm not sure about that -41. I'm pretty sure that's where something went haywire. So you could work this out, but you understand the process. And the process is simply to get the equation of the line, you first find the slope. Hang on a minute. We have a comment here. Maybe somebody will tell me what bonehead think I've done here.